Welcome to Bits and Chips and welcome to the second part of my interview with Jonathan Müller. Last time I talked with Jonathan about the technology behind the EUV drive laser. This time we talk about culture, how Trumpf, as a traditional German machine builder, had to adapt to the ASML way of working in the semiconductor market. Jonathan, welcome back. Let's talk about system engineering at Trumpf and ASML. It's known in Holland at least that the engineering cultures and the also entrepreneurial cultures in Germany and Holland can be very different. And I'd like you to tell about your experience in system engineering and actually maybe also tell about what the whole Trumpf team had to experience getting to know ASML and work efficiently with the Dutch company. We know, for instance, that the cultures of, for instance, ASML and Zeiss are very different. Yeah. I understand from conversations with you that the Trumpf culture is also different from Zeiss or ASML. Yeah. Maybe you can take us, give us a look at that story. What did you experience? So maybe you can first explain to me what the Trumpf culture is, because it is actually you're producing, your core competence is lasers and using lasers to make machines that, for instance, machine metal.
Metal machining.
Yeah, yes, so that's a very different environment from EUV sources.
Yeah, well actually it's even a bit different than that. So historically what Trumpf started with is machine tools at a time where lasers were not yet developed at all, so somewhere in the 30s or 40s. So metal machining at the time was done mostly by the predecessors of what we today call punching machines. Mm-hmm. So that is like the historical, where Trumpf comes from, and it's really from a workshop how they started. So very much hardware focused. Also engineering focused, but engineering was not about system integration as ASML. It's about finding smart solutions to do simple things like metal cutting or metal machining or so also in a cost efficient way. And that means that historically the Trumpf culture is very much like, smart engineers go to the workshop, have some smart ideas, bring it on paper, test it, reiterate it a couple of times until they are happy with the process, and then it's brought into production. Mm-hmm. And I mean, metal machining is not a very dynamical business in the sense that innovation cycles are much longer than in semiconductor typically. And that means also that the time pressure is not so high. So whether a new machine is released half a year earlier or later, at least in the past, it didn't make such a big difference, right? And
that was also still in the 90s.
That was also still in the 90s. So Trumpf was mostly producing lasers for that application. So for our own systems, of course, or our own metal machines. Metal treatment machines, so laser cutting, laser welding, and so on and so forth, but also for customers who build their own machines, or would also sell the laser without a machine around it. But still the tradition is somewhat different, totally different environment, different type of business. Yeah. And then ASML kicked in.
Yeah, but one step back, Trumpf was a company that was innovative. They didn't like buy lasers decide to buy lasers from the shelf. They decided to develop them.
Actually, at the time, they started to develop. There were no lasers by the shelf. That's the reason that we started to building them, because there was no lasers available on the market that would meet the demands in terms of power, but also industrialization. So stability, robustness. I mean, if you think about a metal workshop, that's not the most healthy environment for a laser. It's very dirty. There's all kinds of temperature fluctuation, and so it's by far not a clean room environment as we have it in semiconductor, where everything is very much controlled. So they needed to develop laser sources that are robust enough to survive in that environment, and also laser power was of course the driver. So to cut faster, to cut thicker material, that was always the driver for innovation in the past at Trumpf.
Now, in the last episode, you told us that Trumpf met Cymer at a trade show.
Yeah.
Maybe you can tell us about the stages that you about this adventure. How did you get to know ASML? You were not there in the first years, but you probably know the stories.
Yeah. So actually, in the beginning, essentially, what ASML or Cymer, they just wanted to buy a laser and do it themselves then. So integrate it themselves, not really tell us about the application. It was also kind of secret at the time what should be done with it and how exactly it would be integrated. So they just kind of, well, as it often happens, they handed over a spec sheet and said, please deliver this. And then we just shipped it and never heard about it again.
But you still had to especially develop a laser, or was it a laser from the shelf?
It was a special configuration, but the fundamentals were laser from the shelf. So taking essentially components that are also used in metal machine tools, so laser amplifiers, some mirrors and so on, and then put it together in a different configuration, but it was not like building new technologies from the scratch. I mean, in the end, they picked us because we already had products available that were close to what they needed. Yeah.
So small adaptations were needed.
Relatively small, yes. And then at the time, basically, the whole system engineering was done by ASML. So they decided they took a laser, took mirrors, and then built it together the way they wanted it. Sometimes they asked Trumpf to build it in a certain way. So specific configurations, they had specific wishes how they wanted the mirrors to be arranged, for example. But then basically we just put them there where they wanted them to be.
Without knowing why.
Yeah, with knowing somewhat, of course, it's never as black and white. But essentially, the responsibility of the system engineering was at ASML at those times. And then later on, we started delivering more and more modules of the source. So mirrors for different locations, but then also the seed module that we talked before in the very beginning was not a Trumpf product, but developed by ASML. And then only at a later stage, so somewhere in 2016 or so, the R&D responsibility for that product was transferred from ASML to Trumpf.
Oh yeah. So ASML in the first stage built its own seed laser, and you provided the CO2 lasers who amplified the beam from the seed laser.
And that means then, if you think about it in terms of system engineering, that basically the system was engineered by ASML, and Cymer at the time, we provided like modules or components.
Which at that time made sense, but because Cymer had a lot of experience in lasers.
Yes, I mean,
Cymer laser experience.
Yes, and they just wanted to keep the kind of the know-how under their control. Yeah. And then it was a process over the years to essentially shift the responsibility for the whole drive laser as a system to Trumpf. Yeah. And that has only the full responsibility has only been transferred very recently. So that
And Cymer was acquired by ASML in 2013, if I'm correct. Must have been also a cultural difference, because Cymer probably is a laser company. Yes. They, of course, like to protect their IP, especially when they work together with another laser development company. Was there a difference in attitude when Cymer was acquired by ASML?
Yes, yeah, absolutely. I mean, Cymer is also US-based, very much R&D focused, while ASML is, more on the product side. So, and then of course you can imagine that if a company is bought by another company on a different continent, there's a lot of fears and so on also involved, because of course Cymer people did not yet know at that moment so like 2015 or so, what would happen to them, what the long-term plan was, whether ASML wanted to take all their IP and essentially close down the San Diego site or so. That was for us, of course, tricky because we negotiated partially with Cymer or former Cymer people, ASML San Diego, but also with ASML Feldhoven, and the relation between those was not always easy. So between the two different ASML sites. And we were sometimes like caught in between.
Yeah, because there was still a cultural difference. They weren't at the same level at that time, or cultural level, you could say. Yeah. So there was a different tone in communication.
Yes, but I think you would have to talk with some guys from ASML on that topic. So I'm only the external guy looking from outside and seeing how things are going and what struggles we had at the time with that.
This is, of course, about your experience. You just told me that the seed laser was transferred to Trumpf. Yeah. And that's only recently you told me?
The seed module was transferred to Trumpf in 2016 or so. Yeah, so it's quite a while ago. Yes, and so at the time, basically a new generation of the seed module was developed, and that new generation was then developed by Trumpf, not by Cymer anymore. But the predecessor had been developed by Cymer.
And what did you discover? So you got the IP, and you looked at the seed module, and what did you think? Well, this is.
Yeah, that was actually, of course, then the point where the cultures kind of clashed, because ASML went in with their first time right approach, right? So ASML always has the philosophy of going to the customer as early as possible, being super aggressive about market introduction. So they just asked us to build this thing first time right, but we had essentially no clue at the time how this worked. So building something first time right doesn't mean that you just design it and then do not test it. Yeah, there's much more behind it that you have to do in order to make sure that your design works without prior testing. And that was something that at Trumpf we were not at all used to. So we were used to building a first prototype, reiterating, building a second prototype, building a third one until it works. And basically the moment of introduction is driven by the moment you have a working concept. Yeah. And this was the first time where we had a product where basically the timing was defined from the beginning, and it was really designed to target also timing-wise. And there was no real full demonstrator of the series design before, and that meant that we had a huge mess up, because of course then if you're not used to it, you do all kinds of mistakes that you typically solve on a prototype. You just find out, okay, this doesn't work, I will do it differently. But if you start your series production with your first prototype, then you have to solve all these issues while your series is already running. Yeah.
And this might be normal with ASML, but
was not normal for us at all.
So actually, you took a little bit longer. You wanted to take a little bit longer time to get things right.
Yes. Well, that would have been the traditional approach at Trumpf. And if you want to do first time right, then you have to start with proper system engineering, of course, in the first place. So start with full budget breakdowns of basically all the critical KPIs. Think about how it works, and then also do appropriate de-risking. So in the beginning, very carefully check where do I have risks, where I'm not certain that something works, and then figure out how you can solve this. Contain the risk without building a full machine prototype. So like building a functional model of the specific part or so, even before. So building model of your, for example, a mirror holder or something like this, way before you know where it will be actually go, because you know, okay, mirror holders is always tricky. I want to build a functional model of this one that I can thoroughly test up front on a very, very rapid cycle. And at the time, we just didn't do this because we were not used to it, and then had all the mess that comes when you basically throw premature products on the market.
Yeah, but what did actually happen? You started to develop the seed laser.
Yeah, seed module is. So it's not only seed laser, it's also the amplifier. So seed laser we only call the very first stage.
Okay.
Yeah.
The whole seed module, you had to build that.
Yeah.
So you start rebuilding that, and ASML said you're going too slow. Is that the...
Yes, well, basically they just hammered on the timeline as always. Then we delivered very early, started to ramp up production very early, and then had to solve things while production was already running. And that was really stressful times, because we had to constantly send out development engineers to the field to solve things there on machines that were already built. At the same time, we had to start projects to fix all the bugs that we had found. And that was really stressful. Also because at that moment in time, we were not yet into high volume manufacturing. So the whole EUV conglomerate at that time globally was still burning money, right? So it was not like a few years later where basically money was not a problem anymore. It was just about output. At the time, EUV was just burning money for everybody. So the stress level was really high because it was not yet proven at the time that it would actually work.
Yeah. But at ASML they're used to go to fabs. The whole engineering team goes to fabs if necessary.
But for us it was a completely new thing. So. And then there was like also new stuff like for our standard customers, if you have a hose, it's a water hose on the laser, and it bursts because it gets stuck because you have some contamination in the water or so. Well, what they do is just, they clean up the border, take a new hose from the shelf, put it in themselves. They will not even call Trumpf for this. Yeah. If you have a water leak in the clean room and if you have a few tens of liters of water on the floor, you have a huge escalation. If this happens at TSMC or so, because you have unknown liquid on the floor, worst case the factory gets evacuated because of this, because they don't know what it is, because it's just an unknown liquid. So, and for us this was never a problem in the past that we had like bursting hoses on those lasers, but it was all of a sudden a problem at the moment we entered into semicon. Yeah,
you just didn't know enough of that market.
Yes. And we knew our product quite well, but not for this application, where still some things in the environment are much different than what we were used to.
So even normal water, clean water, which is sprayed into the fab with an accident, this gets escalated because it is an unknown contamination.
Well, unless you can detect it properly and can say, hey, it's only water, it's me, but I don't worry, and I have a solution also. So then you have some mechanisms to essentially collect the water and dump it in a way that it's not so harmful. Then they will not shut down the factory, of course. But in the beginning, this happened, and nobody at Trumpf knew that the hoses would burst because the customers wouldn't tell us because they didn't care, because for them it was just replace a garden hose type of thingy that they can do themselves.
Maybe you can tell us how these cultures came together. How did you learn from ASML and ASML learned from you? Yeah,
well, I think the thing that like cultural-wise is quite strong at Trumpf is just to build functional models and build prototypes and do de-risking hardware-based. That is something that ASML hardly does. So they at ASML, I always perceive that the engineers are typically kind of stuck behind their desk and they do all kinds of simulations and calculations before they start to get to have some real hardware in their fingers. Mm-hmm. And that is, I think, how it should be combined. So I think what Trumpf has to learn from ASML is to use calculations and simulations in a smart way, and really figure out, because for some problems it's just a faster way to find a solution. So if it takes you a year to build up a prototype and 6 weeks to do the simulation, then you should do the simulation. But there's also problems which you cannot properly tackle by doing simulation. Yeah. So if it's about interplay of materials and friction and so on, then you just need the hardware, and it's also easier and cheaper to do the de-risking hardware based. And that is, I think, where the strength of Trumpf is somewhat. And what we learned in the last years at TLSM, so the EUV part of Trumpf, is how to combine this in a smarter way. So do first time right, yes, but do it in a sensible approach where we do proper de-risking before of the technologies, and then choose the right method for de-risking, which can be calculation, simulation, analytical, whatever, but like non-hardware based. But often it's also good to do it hardware based. It depends on the risk really that you want to tackle. And that is, I think, the key learning where we have improved a lot over the years.
Yeah, Gerrit Müller told me, that's a system architect from the Netherlands. He said that in the ASML history, you saw a lot of companies that were acquired because they didn't perform, or they didn't want to invest, they couldn't handle the technology. Like, for instance, Cymer or Berliner Glas, both didn't want to really invest or had the guts to invest in scaling up with EUV. But Trumpf has this strength to do it and also take on this development.
Yeah, yeah. I think there's two aspects to it. One is that Trumpf is still family owned, and at least I suspect. I mean, I don't know, but the family just didn't want to sell. They didn't want to give control over their company, also not partially. But I think the other aspect is then that the consequence of this was that we needed to adopt heavily to the way ASML works. So that to kind of release that pressure, and that means that really at TLSM, so in the EUV part of Trumpf, we are much more ASML-like in the way we work than we are Trumpf-like. So we see this often if we go to other subsidiaries, because they still deliver modules that we use. So for example, the RF generators, so the electrical modules in the cabinets. The key module that is produced by a Trumpf subsidiary in Freiburg. And if we go to them, then we always have a clash of culture Trumpf internally, because we are so much ASML-like in the meantime. So that means pretty direct in communication, always pushing for the timeline, also kind of so tackling risks. So like there is that cliche about German engineers that they're basically totally afraid of risk. Is essentially a German engineer, if they have an idea, then they will first develop it all the way to the end until they have a working product, because they like to go to marketing and say, okay, now you can sell it. That is how German engineers prefer to work. And ASML is the complete opposite. So they will sell it way before they started the development. And those cultural differences we also have Trumpf internally in the meantime, because we are so much adopting the way of work of ASML.
And how did you get to this stage, or this level, or this other culture?
Well, there's different aspects to it, obviously, but first of all, it was just needed. So ASML pushed us hard to basically do things their way. So follow their development process, do milestone reviews, design reviews, and so on, the way they do it.
How do they do it? How do they push you?
Well, in the end, they ask for it. So in the past, there was typically a Trumpf project organization for new developments and an ASML project organization that basically mirrored the Trumpf organization. Sometimes they were equal in terms of people, so you had 10 developers at Trumpf doing the work and 10 developers at ASML essentially supervising the Trumpf people. And then, of course, asking for all the check gates that they were used to have for internal projects. And we were just pushed by ASML, but of course also our management was involved in this and kind of supported this, that we deliver the same quality check gates and so on that they have internally, and then we also had to adopt the way of work. So it was really working together quite closely on all technical levels. So basically every Trumpf engineer had their counterpart engineer at ASML.
What was needed in the organization to achieve this, to get this communications line like more or less on the same level? Did you change your organization?
Well, essentially, we typically build mirror organizations to what ASML has. So that we just have very similar roles that they have, so like project leads, architects, and so on.
This was the second part of my interview with Jonathan Müller. Next week we will publish a third part, and after that we will follow up with an interview with Matthias Wissert, who is R&D boss at Trumpf. Thanks for watching.